Good day, ladies and gentlemen, and welcome to this short clip on understanding the Prokon Anchor Bolt supplementary reinforcing. My name is Jacobus Oberholster. I'm an AEC and Prokon technical consultant with Micrographics. You can see my email address there in the bottom left as well, so you are more than welcome to reach out to me after watching this vlog as well if you have any other questions. But without further ado, let's jump straight into this short clip. So looking at the anchor bolt module, which is located over here, it actually forms part of an extended workflow from the Baseplate module. All right, so we're just going to look at Baseplate quickly. And the reason why this is an incredibly useful tool or workflow is that Baseplate in itself is a design link from within SUMO, meaning that you can actually get all of the information here. You have your anchors and the anchor information as well as their layout. You can proceed through your normal design. Right, so just going to go through the design, and then within the output tab, you can actually export the anchors with the geometry to the anchor bolt module, which of course it will record the forces in each of the anchors, the anchor sizes, as well as their layout. Right, so what we're going to do is we're just going to look straight into the anchor bolt module itself. So we're not really interested in that workflow here particularly, but there is another resource where you can look at the integration between these two modules in a bit more detail. All right, we're interested in anchor bolt, and we are going to look at the supplementary reinforcing check and exactly how to interpret it. All right, so I'm just waiting for this module now to launch. I'm just concerned about clicking again because then we might have a problem, but let's see. Let's see if we can do that and maybe just refresh its memory a little bit to say, hey, we actually want you to open up. All right, there we go. So here is the anchor bolt workspace, and I'm just going to make use of the simple layout. All right, so this is the simple layout. Here is some general information on the base. We have information on the anchors. Of course, now you've got three anchor types, so headed, mechanical, and chemical, which is really cool. You've got your anchor layout, your base, reinforcing as well. And this is something that we are definitely going to chat about. And then you've got your loads. And then within settings, you've just got the number of mesh elements, selected load case, etc. Right, so from here we proceed to the design space. It runs through all of the different designs, and the first thing that comes up is supplementary reinforcing. All right, so before we look at that, just going to go through steel. We can see that the steel check passes. All right, so it's highlighting the critical anchor, not saying that the anchors failed. We look at concrete cone, and we actually do have concrete cone failure. All right, so what I'm going to do is I'm going to try and see if I can get this concrete cone failure to pass. So I'll go back to input and my anchors, and I'll actually just make my anchors a bit longer. Let's hope that that works. I don't think it'll solve that problem entirely. Let's see, 97.067. Let's give it a bigger anchor as well. Okay, so it says here the end plate thickness is less than 40% of the bolt diameter, so we're going to have to change that. And it says the end plate lip length is 5 mil. Okay, so we need to increase that one a bit, and there we go. Right, let's hope that this works. You know, such a minor, I don't think even there was any increase in that. And I think let's rather address the base then, because that will definitely have an impact. Let's make the base bigger in every direction. Go, give the anchors slightly more depth as well, just to be sure. And let's go back to our design. All right, and here we see we've actually got a pass on our concrete cone. All right, and our supplementary reinforcing at this stage also doesn't have a problem. I'm going to see about changing the anchor diameter again back to 24 and actually decreasing its length. Let's go to design Let's see. Okay, everything is working. Okay, cool. And we've got failure and we have got a pass. All right. So this is exactly what I was looking for, the scenario. So we've got concrete cone failure. So the concrete cone failure passes, or the concrete cone failure check passes. So we don't have to worry about that. But we have failure when it comes to our supplementary reinforcing. Now, this could be confusing actually, because the supplementary reinforcing is specifically there to assist or to work against concrete cone failure. So how does the concrete cone check pass, but supplementary reinforcing doesn't? Okay, so let's just firstly look at the little model over here. You've got blue sections and you've got green sections. And so the blue section indicates where that cone intersects the bar. All right, so from the head of the anchor itself, you have a cone at a 45-degree angle. And where it intersects that bar, you'll see the change in color. Now, of course, for this rebar to be effective, it must intersect the edge of that cone. Right, so if your rebar is too far away, it won't have any effect. It won't resist or assist with preventing concrete cone failure. So we can quickly look at that by going to reinforcement and reinforcement details. And what you'll see around every anchor, there is this circle. All right, so this circle indicates the top of that cone. All right, so the cone progresses from the anchor tip upwards at a 45-degree angle to the surface of the concrete base. Now we can see here that there are actually bars that do not fall within that, let's just call it influence field, or whatever we might want to call it. And we can actually increase the size by just increasing the depth of the anchor itself. All right, so if we take note of this, I'm going to go back. I'm going to increase the depth of this anchor maybe to 700. And let's see if we can actually get, we can actually get those rebars with inside that influence area. And you can see now that all of them are within, and we can actually now bind those bars to or assign those bars to specific anchors. All right, so just understanding that sphere of influence or that area of influence and where it comes from. Okay, so that is one of the ways that you can address maybe some of the problems you have, especially if you have supplementary reinforcing failure and those sort of things. But importantly, if you don't have concrete cone failure, you can actually skip the supplementary reinforcing check, because the whole reason for the supplementary reinforcing is that it mitigates concrete cone failure if it is there. All right, so in this circumstance, there isn't any concrete cone failure, so therefore we don't have to worry about supplementary reinforcing. Now, in the event that you have concrete cone failure, you can then proceed to supplementary reinforcing and adjust the parameters until all of these rebars pass and you don't have any failure. That means that your design, in terms of the concrete cone failure, is then complete. All right, so if you have concrete cone failure, you don't have to worry about supplementary reinforcing. So even if these bars fail in the supplementary reinforcing check, that is not something to worry about. If you have concrete cone failure, you can check your supplementary reinforcing and adjust the parameters so that none of those rebars fail, and then you can proceed on with your design and you have mitigated concrete cone failure. All right, so I hope that is helpful. I hope that is insightful. If you have any feedback or any questions, please, you are more than welcome to pop it in the comment section below, or you're welcome to email me directly if you have any questions. Thank you so much for tuning in. I hope you've enjoyed this clip and look forward to seeing you in future clips.